Hello, my darlings. We are starting our first set of notes for transformations. So hopefully you already did assignment 1, which was to find something on the internet that talks about the different types of transformations. And so those are, there's 3 of them that are rigid transformations, and then there's dilation, which is not rigid. So the 3 we're going to be focusing on are the rigid transformations, which are translations, reflections, and rotations. And what I mean by rigid is that the 2 shapes are congruent to each other. Alrighty, so today we're just looking, for this set of notes, we're looking at translations. Okay, so a translation takes a shape and slides it to a new position. The original shape is called the pre-image, and the new shape is called the image. And basically, as I move the lightsaber across, the lightsaber is doing a translation. It's facing the same direction, it just slides across the paper. All right, so to do this, we use these rules where we take the original points and then it tells us what to do to them. Like this one says add 4 to the x and add 6 to the y. So we take our original shape, which I have the points listed here, and to each of the x values we add 4, to each of the y values we add 6. So I goes to the point 1, 2, J goes to the point 4, 5, K goes to the point 4, 3, and we graph this, and notice these little tick marks, we read that as prime, so this is now I prime, J prime, and K prime. So the pre-image is IJK, the image is I prime, J prime, K prime. So this is the pre-image and this is the image, and these are the coordinates. All right, so this one, xy goes to x minus 1, y minus 4. So this says take each of the original x values and subtract 1. Take each of the original y values and subtract 4. So t becomes -1, -3. U becomes -1, -2. V becomes 1, -1. And W becomes 3, -4. So that's the original shape, and this is now the image. And notice I said T prime, U prime, V prime, W prime. And notice these 2 shapes are congruent to each other. They're the exact same size and shape. These 2 shapes are congruent to each other. All right, so the next example, we're given the image and the pre-image, and we want to figure out what the rule is. So first thing you need to do though is look for the prime, because down here there's no primes, up here there are primes. So this is the pre-image and this is the image. So we want to go from this shape to this shape. You can pick any of the letters, it doesn't matter. So I just chose, I can't tell, I think that's a U now. And I figured out how do I get from here to here using just left, right, up, down. So similar to slope, I would go up 5 and to the left 3. Up is a positive number, to the left is a negative number. So xy goes to, well, I went to the left 3, so that applies to the x minus 3, and I went up 5, that applies to the y plus 5. All right, so the next part. So again, these are the non-primes and these are the primes. So we go from the pre-image to the image. And again, you can pick any letter, but you have to go from that letter to the same letter with the prime on it. So I chose here, and I went up 5 to the right 2. Okay, so that means to the x value, I'm going to add 2. To the y value, I'm going to add 5. And yes, you have to put this first part. The rule is xy goes to x plus y, y plus 5. You have to write the whole rule down. Now, sometimes math people kind of tend to be a little lazy. They want to write as little as possible, which is why there's a lot of notation to learn, because they don't want to write out the words. Math people tend to not want to use words if they can help it. So another way we can write this is called vector form. And basically, xy goes to x plus h, y plus k. In vector form is just hk. This means to do this. So like here, if I wanted to start here and end here, I would have to go to the right 11 and up 5. So that would be the vector 11, 5. If I wanted to start at this point and end at this point, I would have to go to the right 12 and down 16. So that would be the vector 12, negative 16. It acts just like a point in the fact that the x value always comes first, the y value always comes second. So this would mean x plus 11, y plus 5. This would mean x plus 12, y minus 16. All right, so here we're given the image and we want to figure out where did we start from? What was the pre-image? So if this is P prime, the original point was the point P, x, y. And if I apply this vector, it says subtract 5 from the x, subtract 2 from the y. So that means x minus 5, if you look at P prime, would have to equal 4. And y minus 2 would have to equal negative 1. So if I add 5, I get x equals 9. If I add 2, I get y equals 1. So the original point is the point 9, 1. Because think about it. 9 minus 5 would give me 4. 1 minus 2 would give me negative 1. So same idea here. We have z prime, so I want to know what was the original point z. And here's our rule, which tells me x plus 8 would give me negative 3, and y minus 6 would give me negative 7. So I'm going to subtract 8 from both sides and get x equals negative 11. I'm going to add 6 to both sides and get y equals negative 1. So my original point was the point negative 11, negative 1. Which makes sense because if I did negative 11 plus 8, I would get negative 3. If I did negative 1 minus 6, I would get negative 7. And that finishes up translations.